Good afternoon, ladies and gentlemen. Thank you for attending Improving's May 28th Virtual Lunch and Learn. We are thrilled to have you join us today. Before we start, I want to inform you about a feature in the presentation that'll make the session more interactive. Please make note of the question mark icon at the upper right of the presentation screen. Clicking that icon will open the question and answer feature, which allows you to send the moderator questions to be delivered to our insightful presenter at the appropriate time. Speaking of insightful presenters, I am proud to present Daniel Scheifler, who is a software developer at Improving. Today, Daniel will be sharing a webinar titled Code is Red. The floor is all yours, Daniel.
Thank you very much, Sherwin. Welcome and good morning to everyone. Thank you for spending a little time joining with me over this wonderful Friday. Now, as he mentioned, this presentation is titled Code is Red. But before I get too far, I want to inform you guys about a free virtual conference which Improving is organizing on the week of June the 7th. Which is called the Improving Edge Conference. If you find this talk to be insightful, enjoyable, or something you'd like to get more of, please give it a look after this presentation. We'd be happy to have you. I'll give you some more information about what's being done in that conference at the end of this presentation. So without too much further ado, who am I? Hi, I'm Daniel Scheifler. I'm a Christian husband, father, and improver, most recently, and I'm very happy to bring to you some of my experience distilled into this presentation. One of the quotes I like to try and bring to every one of my clients is to see with eyes unclouded, to see what is truly there and what is truly going on as part of our day-to-day work. And it is these kinds of insights which have led me to some of the content I'd like to share today. So our agenda, we'll be able to discuss the goal of our work as software developers, which is, to a large extent, coding. We'll talk about some of the principles that make for more readable code that I have been able to ascertain, and how we can apply the development patterns and the tests and all of the other good practices we know about into doing that. Now, before we get too much further, I would like to point out, as Sherwin said, you are going to be able to ask presentation questions as we go through. When you see that little symbol up there at the top, ask your questions now. It'll be a good opportunity for you to open up that Q&A feature and throw in a comment, because up until that point, if you had any questions, feel free to throw them in and Sherwin will route them to me when I get that chance to pause. So let's practice that right now. The goal. What is the goal of software development? And in particular, I want to ask you, what is the root activity of software development? And if you can, focus on the existing projects, the brownfield projects, as they're called, as opposed to the greenfield. So tell me, what do you think? All right, Sherwin, are we getting any fun responses from the crowd just yet?
We have bugs, we write bugs, we fix bugs, and feature creation.
All right. All those are actually very good answers. I can definitely jive with a little bit of the jaded response there of we write bugs. Yeah, a lot of our time in brownfield projects is going to be spent writing software that later ends up being buggy or fixing someone else's bugs. But that's not really the root activity. I mean, no one sets out the beginning of there to say, you know what, I'm going to write an absolutely killer bug today. Now, of course, that argument can't apply so much to our feature creation, which is part of what we do. But strictly, we don't actually write features. Features are an outcome of the root activity, which we do. They're the thing which the business really wants from us, but we have to do something else to get there. Do we have any more responses out of that, Sherwin?
No, Daniel, we don't right now.
Let's go ahead and move on. I would like to submit to you that the daily activity of the software developer is to change code. Writing bug requires changing code. Fixing a bug requires changing code, although it requires a little more than just changing code. Because in order to effectively change the code, you have to understand it. You can't just guess and check your way into a new product development. That doesn't work. That doesn't jive. If you read from the Pragmatic Programmer, they call this, honestly, programming by coincidence, unless you know what it is you're changing and, in particular, why. So our goal, like the daily activity of doing all of this, is to change code, right? So why do we care about readable code? Readable code allows you to understand the code you're going to change faster. The faster you understand it, the more able you are to make an effective change. That is, you make the changes faster, which at the end of the day leads us to be able to deliver more value to our clients faster, because we were able to understand not only what they intended, but what we were intending when we wrote the code. moving along, there are some principles that I'd like to lay out that allow us to build a foundation upon which readable code can be understood and crafted. And it all starts with this basis. A few years ago, I was tinkering around with Python. It was one of the first languages I went and taught myself. And I fell in love with this language because it felt to me easier to describe what I understood to be useful and readable code, especially because it made simple things like a for loop just feel like a terse form of human instructions. And instead of getting caught in all of the curly braces and all of the setup and all of this, it's very pure, very simple, do the job. And so I started getting into the Python culture and reading especially their documentation in the form of the PEPs. And one of these caught my attention. This is PEP 08, which is a readability and coding standard document for Python. And it reads thus: one of Guido's, that is the inventor of Python, Guido von Roysum, one of his key insights is that code is read much more than it is written. The guidelines found in the PEPs provided here are intended to improve the readability of code and to make it consistent across a wide spectrum of Python code. As PEP 20 says, readability counts. Now, I will strongly recommend to you definitely go back and read PEP 08 and PEP 20, which is commonly called the Zen of Python, as they both include a lot of good and repeatable information, not just specific to Python, about ways to write for readability. But I want you to focus again on that highlighted piece. Code is read way more frequently than it is written. This felt like a duh statement at the time, but I didn't understand it when I read it at first. It took until I had taken a vacation a while back to beam me across the head. I'm like, oh, because if code is read more frequently than it is written, since it is read most often, we ought to make it easy to read. It did not state it outright that that was the intent. But if you're going to optimize for value, why not optimize for the case which will be run the most frequently? We do the same thing in performance testing. We make certain to make the trade-offs for the one that is the most common and therefore most likely to be the highest value. Now, with that as our basis, if code is read more often, we ought to make it easy to read. I need to ask you, who is code for? All right, like if our daily activity is to change code, that's well and good, but who are we writing the code for? Because it's kind of important as it alters our ability to make it readable. Is it for the computer? I mean, there may be an argument for that. I've heard people say, well, you have to write it this way because otherwise the compiler can't understand it. Okay, there's some syntax issues there, sure. But at the end of the day, does the compiler ever see your variable names? Does the CPU care? No. 90% of our code ends up getting extracted away, optimized out, or completely replaced by the compiler, by the transpiler, by whatever interpreter between your actual code file and the binary that ends up getting executed on the client's machine. So at the end of the day, code, saying the code is for the computer is not really accurate because the computer never sees that version of the code. It sees something else and is constantly pulling away from your code to optimize for execution. So trust the compiler to do its job and realize that the code wasn't ever intended just for the computer. Which leads us very naturally to suggest, oh, maybe it's for the business, those people who are paying us to write the features, right? I don't know. Have you ever asked the business if they want your code? I'll bet you they don't. What they want is the feature your code provides, the behavior, the repeatable behavior that your code produces is what they desire. They don't want to have to pay someone to crunch the numbers for the next 20 years. They want to have a computer do it and produce the right result. They don't want to have code that's 5,000 lines to do it, but frankly, if they could get the behavior without the code, they'd do it in a heartbeat. So your code is not strictly for the business in that regard, because the business wants the behavior. They don't want your code. So then who is code for? Here, I will suggest that the audience is really us. Code is written for other developers. It is the communication of ideas and intents between us. And that will include yourself in the future, because everyone has had that experience where they wrote some code about 6 months ago, there's a bug reported, and so they start hunting it down. They're like, who in blazes wrote that code? Oh, it was me. And that experience being so common, tells us a lot about our ability to practice writing it for the right audience. Because at the end, that's the use case you're going to need support. You being the last person to touch the code are going to be the one called on to fix it. So if you can't remember what you knew 6 months ago, you're kind of up the creek without a paddle. So remember that when you're writing code, the audience matters. And the audience is other developers, people who are or may not be familiar with the why behind the code, people who are familiar enough with the syntax that they can read it and understand it, people who are maybe familiar with the business, but not 100%. And so you can rely a lot on the background of these people without having to be strapped. So here's the first principle I wish to share. Be informative. Now, when I say be informative, I want to start with this easy example, right? When we're all writing code to start with, and I'm about to write in a new feature, I might start by initializing a variable temp, which in this case says the invoice's billing total is greater than 1,000. Now I've got no units on that, so I'm going to presume since it's an invoice, it's dollars, but that's not really defined. But like if I'm just scrapping this code together to see, is this really the logic I need? Sure, throw temp in there. But please, oh please, don't leave that. And so oftentimes I'll see this be the next step. They'll say, okay, so it's no longer temp. I'm going to rename temp to the billing total is greater than 1,000. Okay, that is better because now if temp gets separated by a lot of distance, I might remember what that meant. And so, yeah, billing total is greater than $1,000. Okay, I can see that. And I can see immediately I'm going to do something if that's the case. And the sentence reads, okay, if billing total greater than $1,000. But do you see where that could become a problem? Think about what code does. We said the daily activity of a software developer is to change code, not to leave it the same or just to read it, but to change it. If code changes, we run the risk that our names don't change and keep up with it, which leads to unreadable code. Something a little like this, where my sum better function ends up with the billing total is greater than $1,000. And because the users decide, you know what, $1,000 was right for that account, but I need to use something else for this one, I now have to go start loading it from a configurable variable. So the config.credit limit. And now when I read this code, I say, okay, billing total greater than $1,000. The invoice.billing total is greater than config.credit limit. The name of my variable implies that credit limit is $1,000, but I don't know that. It could be 1,000, it could be 500, it could be 2,500, and I won't know. And therefore my code will mislead me, because if I go through this and say, okay, so I'm supposed to make certain that if it's over the credit limit, I do this work, I won't know to go look at the variable there because it's not named with what it is or what it does. So there is a difference here, because the previous examples you've been seeing have been descriptive, not informative. Now, our goal is to be informative, not merely descriptive. And the major differentiator is that descriptive ends up being a declaration, almost a repetition, right? It says the billing total is greater than $1,000 is a statement. It is or it is not. Okay, that's useful. But with the informative, I'm trying to describe the why do you care? I am the answer to why. So if we look at the code, we see that comment down there, do something. Okay, if that's the case, then I'm really looking at whether I should do something. And the variables going backwards up should be called should do something, because that's the answer I care about. Should I? Yes or no. It also allows you to see where you can derive some more informative names, because the name can now come from your domain, from the actions you intend to take on the information, on what that information actually represents. Here, the action is a decision. Should I or should I not? Other places, your content may be the grouping of certain sets, or it might be the condition of something. But naming it in that way allows you to understand and manipulate the logical parts and the concepts together in a way that just calling it billing total greater than 1,000 does not. Now, informative method names, those can be a little difficult because naming things is hard. Thank you, Donald Knuth. So please don't just stick verbs together. Naturally, when you start, it's okay to have a temporary sum function. Don't let it stay there because you have to define What is it doing? What is its behavior? And ideally, you don't end up defining it as check for taxable and compute the taxes and make it ready to post and da, 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 da. That's descriptive. But I could find all of that out by literally going and reading the code under the method. It did not add to any information I did not have. And so finding a way to describe the intent of the method can be very difficult. Now, I don't want to get into examples here because later on in the presentation we'll touch on that. But remember that the intent is the thing and that you can pull on your domain to provide understanding and representation of what that information means. So with principle number 1 completed, I want to move on to principle number 2, be respectful. Remember that code is written for the developers, which includes the future you. Be respectful of the fact that it's going to be a human reading your code, and that human just might be you. Humans are fallible. Humans have limited concentration, and yeah, we're not always all there when things happen. And so we have to make certain to optimize for the human case, not merely the desired case or the beneficial case, but the human who's on the other end. So I want to introduce a concept that I have decided to call wetRAM, right? It takes a certain amount of mental resources in your head to understand the code. You have to compile a bunch of sentences to understand the dense idea and the intended behavior, all for the context that you happen to be thinking of for the example data. So if you have more if branches in your code, it's going to take more resources because now I need to remember 3 things rather than 1. Maybe you have multiple pieces within your if statement. That's going to be hard to remember because now I have multiple of those rather than 1. And remember, above all, that the human side of the resources are incredibly limited. Most people can only remember about 5 things, give or take 2. So if you're asking them always to remember 7, because obviously they can, you're going to be putting it beyond the reach of the average person to actually follow along. And it's going to make it harder for people to understand your code, and therefore more likely that they make a change without understanding the impact. So consider the following. With wetRAM in mind, look at the variable temp. Now, the invoice.billing total is greater than $1,000. And the invoice.rate has a value, or we're in a special state based upon the invoice's location. Or the invoice has a late fee, and every line item on the invoice is a late fee. And then the next thing you look is that there's some feature flag that comes in, a giant wall of text talking about whether or not you should compute taxes, how to do it in this special way, loading them from a new database because the feature wasn't already implemented. And about 108 lines later, after looking at the novel line item that's coming out of this new builder due to the feature gate, we finally get to temp. I mean, again. And so our issue with wetRAM is not merely that there's 6 clauses inside. I think it's 6. Let me see. 1, 2, 3, 4, 5, 6. Yeah, about 6 clauses inside of that statement before I can understand whether or not temp is going to be true. By the time I actually get to using it 108 lines later, I don't even remember what it meant. And so one of the practical applications of being respectful can look like exit early. Oftentimes we'll say, oh yeah, exit early because of the compiler. It'll automatically hit that and it'll just jump over the code. No, the compiler doesn't care. The compiler will evaluate your if statement, 1. It will look at the if that comes up and either go or no go. It will not care how many lines are between the top of the if and the end of the if. It just remembers a location in memory. And so it'll jump over all of the irrelevant instructions and move on. So the compiler has it easy. The human reader, on the other hand, has a heck of a time with it. Just look at this method. How much do you have to read in order to know what you're going to return if there are no line items? Well, it's a lot. You have to read that first if statement and then skip everything down to the else, down there in the bottom, and return 0. Returning early would pull that to the top and makes better use of your reader's limited wetRAM. I no longer have to remember everything about how I'm going to do my line items because I just need to remember if I have 0 line items just in case I need to make certain it doesn't do any extra work. I can ignore it because as scrolling up and down as one will do while reading the code in the IDE, there's a lot of waste. Some motion that gets lost. Respectful, exit early. How much do you have to read by pulling it up to the top? Well, in that particular case, I just need to read the first 4 lines. I get the invoice, I check the invoice for greater than 0, and I return 0 if there are none, because the rest I do not care about, because I am allowed to save my mental resources, because I have found my answer. Think of the cases when your reader is going to be coming in trying to find an answer from your code, and make it easier for them to find it. Not by hiding it, but doing things in the order which is optimized for the human on the other end, without sacrificing the need to make it readable and usable by the computer. And so, get to this concept of a contextual burden. Within the context, looking at that code, there are a ton of things going on in there. So if invoice bill to is null and the rate sheet is null, or the invoice is a special case and the rate sheet is null, then go ahead and do this stuff. And like, okay, wow. But what does all that if statement mean, right? What does that mean? Do I really need to evaluate it, or do I care? So if you take a moment to extract it and say, well, really, that was governing whether or not I could compute the billing total, I can just extract that thing out and throw it in a variable and give it a meaningful name. If I cannot compute, return 0. And I've just answered one of my main questions. Do I need to evaluate the rest of this method? Yes or no? And if not, okay, I exit. But if I do, now I can go find my answer. So what part of the code do I have to look at, for example, if I want to change how those computations are going, because there's a bug in there? Storing a strong name reduces the contextual burden because I can drop the context when it's no longer needed. And it allows me to ignore whole parts of the code. Very related to the wetRAM principle, but lines us up quite nicely by allowing us to take as much of the context as I have been developing in things like, can I compute the bill total? And then dropping it like this when it's not relevant if I only care about the other case. So these if statements actually end up being your friend if you can use them well, with the goal being create the context that is relevant and useful to your users and then drop it as soon as you can so they don't have to remember. And by helping them figure that out, they can read through it and move on. Now, the last step that I would like to suggest, the last principle, is to be trustworthy. Our goal is to change code, ideally in a predictable, effective fashion. We cannot afford for our code to look like it does one thing and then turn around and it does that. That's not helpful. And in fact, it's what usually leads to our bugs because, oh, this thing over here depended upon that, and that over there is also modified by this. Who would know to go look into that corner if I'm trying to change this one? And with that being said, now we need to find a way for our code to understand and to behave in exactly the way that it describes that it behaves. So we need trustworthy code. The good news is you're actually already pretty good at understanding what it means to be trustworthy, right? We interact with humans all the time and make a call. Do I trust them? Do I not? Do I want to let them trust them to hold my baby? Most of the time the answer is no, and that's okay. But at times it's yes, it's because we have gone through this kind of a process. Do they do what they say they will, right? That's the fundamental piece for trustworthiness. They tell me what they're going to do. I can go verify it if I'm really worried about it. And the more I can trust someone, the faster he and I are able to work together to deliver some value. Maybe that's in the purchase of a vehicle, or in ensuring that I can have my children watch while I have to go do something that engages me elsewhere. But trust is fundamental in these interactions, because without it, I'm stuck with a grind of I have to go evaluate all of it myself. And I'm basically redoing the work that someone else already did. At minimum, I'm losing half of it. Multiplied to scale, I'm losing easily 90% of my efforts. Now in the code, doing what they say they will do would likely look like no side effects. It might mean that we are using the pattern and domain names within our problem space appropriately. I'm not calling a horse just because it's a donkey. I'm actually calling a horse and a donkey a donkey. And with those things in mind, now I'm able to have like unit tests, which allow me to independently verify that my code is behaving as I expect, that the donkey is able to lift so much of a load, that the horse is able to run so fast. And by understanding the intent behind a factory and a singleton, I know how to use that code faster because, oh, it's the pattern. I know what that is. I bring in extra knowledge. So I don't need to dive in to see how it behaves in order to know how to use it. I can understand from how it is called. So side effects. Looking at this code here, what do you think the function mark services assigned down there on the second to last code line actually does? Supposing that I have an example service that'll have an ID, presumably a handler considering I'm assigning one, a status ID telling me how it's going, what the thing is actually called, maybe it's disabled because I didn't use it anymore, when the last time it was modified. And I need to reconcile a couple of those as a from and a to. Okay, so my operation would be to take the from service and disable it, mark it as assigned to the handler of the to service, and then save my changes. Okay, I mean, that sounds pretty good. If I go and dive into it, I might find something like this, where mark service assigned takes the service that's being changed and a handler. It assigns the handler, sets it assigned, and then enables the service. Well, there's your bug right there. Now, it might be tempting to just say, oh, cool, so I'll assign it first and then disable it. Yes, that would solve your behavioral problem. But it wouldn't actually help you to understand why reconcile services has to go in that order. Because now at any point in time, just from changing the order of the code, I can break it. That doesn't seem great to me, because now mark service assigned is actually doing a little more, at least by initial interpretation. Because it's not only assigning the service, but it is actually enabling it. Is that part of the domain? In which case, maybe I misunderstood and I need to understand the domain better. Or maybe this function needs a different name and the assign disabled needs to be adjusted. But these questions come about only when you start looking at your code as something to be trusted or distrusted, depending upon how effective it is at keeping its own word. And yes, I have seen this bug in production for real, which is why it becomes so important that your code base is consistent and allows you to trust what is said to mean what it says. Otherwise, you'll spend all day just coming through every method that says do the thing and making certain that it does, in fact, do the thing. Talked about a lot of principles so far. And so I want to transition from talking about principles and abstracts to, okay, so what do we do, George? To actually answer that in the practices section. Now I'm going to take a quick sip of water and I'll answer any questions that have come up until now.
All right, Daniel, we got quite a few. The first one is how to deal with discrepancies in skill levels of developers working in the same code base.
Okay, so that is a fun question. And it deals a lot with the culture of the team you want to build. Taking it just from a code readability standpoint, our juniors are still new at speaking this language of the code. And so they're not as familiar with the idioms and with the spelling and with the little idiosyncrasies that our code base and domain might have. So the thing that I can recommend is that pair programming, especially from a senior to a junior, ends up being incredibly valuable for both. When one teaches, two learns. Your senior is going to get some experience because he's having to figure out why does that matter again. And your junior will be getting the experience of watching someone skilled in the language, skilled in the code base, explaining to them. Now, don't just randomly pair your senior and your junior. You need willing participants. But as far as discrepancies go, I usually try and address that by assuming it is an education problem first and building skill that way.
The next one we have is, are any principles more important to use first? Which would you start with?
Okay, so when it comes down to it, all of the principles interplay. So it will be very difficult for you to follow the informative name if you can't trust your code. It'll be very difficult to trust your code if you have to constantly go back up and evaluate everything because you can't keep it all in context. And so as to starting which one first, start with what you can. I personally believe that principles 1 or 2, the informative names and respectful use of the code, the reader's time, are the easiest places to start because building trust takes time, just like it takes time for it to be torn down. So I start with variable names. Start with naming things in a way that is more informative and, in my personal opinion, reads like terse English. so that it becomes easier to call out, wait, why'd you name it that? Because that generates the conversations that will eventually lead to more respectful code and more trustworthy code.
We got two more. The next one is, should you have the same care when writing tests? Does it matter?
Yes. Sorry. Yes, 100% it matters. Your code, your tests, the whole 9 yards, if you cannot understand them, they buy you nothing. However, the way in which your code has to read and your tests have to read will be different. I am very much a fan of the given when then structure on tests, and I'll actually cover that somewhat a little bit later, because I find it to be the most informative format of the tests. It allows me to hide all of the I need to set it up like this, which is a lot of black box magic that you don't care about if you're not interested in that test, underneath a meaningful method name of given this condition. So if you're going to do your tests, please keep them informative. Where you can, keep them respectful, because sometimes it can be difficult. And if you cannot trust your tests, you're doing something wrong. But yes, your test ought to be treated as readable code, or code in need of being kept readable as much as possible.
And the last one, this person's seeking advice. So I'm a developer, not a dev lead or in IS management. How can I help my team start to improve code readability? How do I start that conversation without offending anyone?
Okay. So let's I'll boil that case even further back. Let's pretend you're the junior on the team. The benefit of the junior on the team is that you basically get carte blanche to ask questions. So lean into it. Don't worry about feeling stupid. And where you learn that people are sensitive, adjust the way you ask, but ask questions. During code reviews, which is a fairly typical process, is a great time. Take a moment to say, hey, why'd you write it like that? As you write your code, start doing all of the practices. That will help generate the conversations, because people will ask, why'd you write it that way? And now you can explain, well, I was thinking about it like thus. Oh, I never thought about it that way before. Or, I don't get it, man. Can you adjust? Cool. Either way, you've found a way to improve code readability, starting with your code. And as you start having more of these conversations, you'll build the influence to start having the discussion at a wider basis. Just start simply. Start with what you own, and then start with questions, which you're allowed to ask. Ask in ways that do not imply they have forgotten something grand and important, but ask simple questions. Hey, why'd you write it like that? Would it make sense to change it like this? You're allowed to make suggestions. And as you find out where people actually are, you can adjust your behavior to avoid having to have conflict, at least some of it.
That's all the questions we have for right now. Correct, Daniel, that's the last one.
Okay, so let's start then into practices. Putting the metal, let's put the pedal to the metal here. Dry. Dry is one of those wonderful practices that we are very familiar with. Do not repeat yourself. Yes, remember, it's not just about code. Applying dry can help you push towards your code being informative. We used to apply it to classes, to avoiding repetition of the code, to avoid the repetition of the implementation of a behavior. Try also applying it to your variable names, because it should apply to the information, the decisions, and the behaviors, and the implementation of the behaviors. Pragmatic Programmer does a fantastic job talking about the different applications of dry across the spectrum of what we do as as coders and developers. And so I'll recommend that's the first place to start. This will help you push towards being more informative rather than being descriptive, because if you look at my example, which one of those is more readable? Invoice billing total is greater than 1,000. Invoice.billing total greater than 1,000.0. Or the billing credit limit has exceeded. The invoice billing total is greater than 1,000.0. One of those literally repeats what you read in the second line. If I name my variable billing greater than 1,000, I have added nothing to you. I have literally repeated myself by repeating what the code will tell you as soon as you read it in another form. I have added no value, and in fact, I probably wasted it if that value ever changes. And so when you're trying to aim for informative and therefore the intent of your code, remember to also apply the thought of dry to information, because the code will tell you if someone goes to read it. But if all I want to know is what this thing is used for, I can't find that out from the name unless I describe my intent to you. When we come to trying to save on wetRAM, speak human. Remember why we're writing the code in the first place. They don't want the code. They want the behavior. It is to solve some human need, some value creation problem. So speak the human language about that problem. We don't have to, always have it in the high developer terms. Bring it down. We can use the domain and really lean on the business domain for nouns and verbs that are meaningful in your context, can help you to describe your problems. Can I compute the billing total? Well, are my line items there? If not, return 0. And that is an improvement in the way that I am now saving on the wetRAM, because I'm describing why do you need to know about that value. If you don't care about whether or not I can compute and just want to get to the computation, ignore these lines. And I'm now leaning on the business domain here because it's talking about whether or not it is feasible to do an action. Now, the business domain can be difficult. Sometimes it can be a little confusing within itself. And moreover, it doesn't always describe everything. That's okay. We'll get to that challenge in a moment. But the business domain should be dominant in the problem space and therefore should be relied on by us to write the code. I mean, ideally, at the end of the day, if you could write your code using the language that the business described the requirements to you in, that in those discussions, building in an agile team and having the discussion with the product owner about, so you want to do what? And you can then piece that together in the code to literally describe, in this case, I want to, so that, and then have the code say that. Imagine how much trust you could build with the business who generally regards programming as some kind of black magic, and literally show them your code that reads, hey, in this particular case, I want to apply this discount to these things in such a manner. They might actually begin not to regard IT as the necessary evil, but as an actual partner in developing value, because you have begun to speak their language. So as you write your code, save on wetRAM by relying on your business domain, using the nouns and the verbs that are already available to you inside the domain, already produced for you by the business. And write your code like it's terse human prose. Naturally, code, we don't want to be super verbose. Code editors are not great for writing English in, and we can't use all of the punctuation. That's okay. A lot of us have had enough practice where reading things in camel case or Pascal case or whatever case you happen to prefer is natural and secondhand. Lean into that so that you can write something that, as I read it, would read like a very simple sentence. If can compute billing total. As I mentioned, speaking human isn't always enough. Sometimes you run into the case where, now how the heck am I going to describe that? And the only answer is, okay, where are cases that it makes sense, speak developer. Using the pattern names. So taking the example of like a factory, right? The business may not actually be about manufacturing. You can still have factories, because this is a way for you to describe to the true audience of the code what's going on. Suppose I have a car factory, right? So factory.make1, a red, shiny, loud, and then car goes zoom, zoom. I mean, I might imagine make one would make one and would make most likely a muscle car. Consider I said red, shiny, and loud. But, maybe it just generates something else. But speak the developer language when it's appropriate. The pattern names help to reduce the contextual burden because they describe the intended use of. And so when we're talking about messaging queues or event sources or just about anything else that cannot be effectively described with the domain, because it is specialized to how we have chosen to solve the problem, it is appropriate to rely on the developer language. Now, that may not apply in every case, and you have to be very careful. There were a couple of people who mentioned, so how do I address the skills gap on my team? Sometimes that skills gap looks like people don't speak the same language. I said factory, he didn't say factory, he said something else. But she meant the same, or worse, I said factory, he said factory, and I meant this and he meant that. You need to find a way to overcome the communication gap. And generally I've found that that's done through education, through discussion, through finding some one set of verbs that mean the common piece, the common tongue across the developers on that team. But you can run into the problems if you start trying to use the pattern names. And for the love of goodness, please don't use just manager, because we run into a million managers and it doesn't mean what you think it means. So remember those cases and be cognizant that not always is it appropriate to use the pattern name. And so you should try first for business domain. Then if pattern name is appropriately and useful and it's shared among your team, you can use it. And where there's a possible gap, help with education so that we all speak one tongue. Now, someone asked, so should my tests also be written readable? Yes, please. Because your tests end up being a means and a gateway for your code to start becoming trustworthy. I don't care if it's unit tests, integration tests, exploratory tests, write them, maintain them, encourage people to use them well. I happen to like automation, but your tests are a means for you to address the trustworthiness gap because it is literally a way for your code to extend and explicitly state, I do this, let me prove it to you. So if you are struggling with side effects, start writing tests. Write unit tests on the function that you have found has the side effects. Write tests that state the side effect occurs. Remove the side effect. Watch the test break. Fix the test that says it has the side effect, say it doesn't, and watch it fix. And now you've stepped up to show that your code took from I did this side effect to I no longer do this side effect. And you can now prove that your test is having the intended effect. Now, of course, this will ripple out saying all of the places that used that method now need to go and explicitly have the old effect. Again, write your tests. If you're running into an issue where like you're completely new to the code base, day one, the one most effective, most valuable thing you can probably add will be tests. Because tests where their place is not covered now provide code coverage. Even if you couldn't add a new feature to the code base on day one, you can figure out how to test it. And yes, that may be hard on code bases which are old and difficult or weren't written with testing in mind. Yes. But if you want a fast way to generate value or you want to explore a code base without making a mistake, write tests. Of course, if you're trying to remediate a less readable module, you have to be able to prove that it still works because the last thing you want to do is to improve the readability by damaging the trust. Build up the trust to know what the code is doing before you change it. Refactor it and verify those tests continue to work. And that allows you to take your steps confidently over time. Now, it does come at the, but I can't do it fast. Okay. That may be true at the start. With practice, though, you'll get better at delivering tests, at writing them, at creating them. And it is acceptable to trade some speed so that you may do things well going forward. And remember that you're not always going to be trading that speed. And as you go, the tests become easier. The tests begin to save you from creating new bugs because they catch when something goes wrong. And as you develop and learn, you'll catch new things with your tests. You'll add new tests to cover cases you didn't think of. And your code base becomes stronger, more secure, more trustworthy, and as you practice, more readable as you go. Because remember, readability is not an all or nothing gig. It starts with you. One person taking responsibility of, I would like to make it easier for me to read this code 6 months from now. By taking that step of, I don't understand why, and asking the question, and then providing an answer. By taking that moment of saying, I want to demonstrate how this code should be used to you. And taking that step to build up something new and valuable for the end user's experience. With that, I'd like to take a pause from the practice to open up the floor for questions. Any questions for us this time, Shervin?
Yes, we have two. Do you think it's appropriate to show code to the business, customers, or stakeholders?
So I admit that I'm coming around to a different way of thinking on this one. When I started, I thought, no, I don't think that makes any sense at all. They can't read it, they won't understand it, and it's just going to scare them. And for 90% of the code bases I have worked with since that time, the answer stayed the same because the code was not really readable unless you knew code. As I have seen better practices, as I have glimpsed possibilities for better options, say a cucumber or gherkin format where you can describe a test case in English, I begin to become hopeful that one day, yes, maybe, it can become not only appropriate, but valuable to demonstrate the code and to literally show it to a business stakeholder in a way to build trust in what it is doing. I like to do this with my given when thens in my unit tests particularly, because having them verify the test case and that they agree that these things are the conditions allows me to more rapidly develop the feature and the value they particularly desire.
The last one that we have is, you mentioned to be careful when speaking to developer. What can I do to help my team use the patterns appropriately?
Okay, so for starters, again, I like to favor an education approach based on this one. Start with just like a book club. If you find out that y'all don't all speak the same thing on the patterns, start with a book club. Do a head first design patterns or design patterns explained. But starting there makes it a we effort, not a me effort, which builds value team. It improves their skills, so most people will be down for it. And it's always a cheap way to score a win for your boss, because he usually wants to find a way to cleverly spend his training dollars. Now, as you go through that, you'll notice that people still try and use them in a different way. And if you're already on the back foot, having discovered the problem and it's already there, the right option is not always go rename everything. Kind of take the moment to pause and think about what the most valuable thing to do next is. I have seen where, in a very particular case, the producer term was an overload from the business domain. So I couldn't use it as a developer term. And originally I thought it was being misused because they kept talking about it like it was a thing, not an object with a behavior. And as I realized that I was wrong, I was able to create a different name for the piece that was producing the messages and just avoid it that way. Where you notice that people are misusing the term, say, everyone's favorite overload manager, start refactoring the code as you go to adhere to a more readable, more usable pattern where it makes sense. You don't have to go on a crusade, and code readability is not an overnight thing. Take your time, build it one step at a time to develop what needs to be developed and increase the value everywhere you touch it.
That was the final question, Daniel.
All right, then I will go ahead and bring us then to this wrapping point. Remember that code is read 100 times more often than it's written, because it'll be read by you and everyone who reads that file after you, even if they're not changing that code. Readable code allows us to more effectively practice development. And as a result, because all of us, I believe, are focused on producing highest value as we go through our daily lives, our daily work, and would like not to have the additional frustration, can value readable code. And therefore, we will want to write code that is easy to read. So to help you remember on this, I put together a little, me being a little silly, I threw together in a haiku. Code is for the reader, trustworthy, respectful, with informative names. These practices are simple. I don't expect any of this to have been a revelatory moment. But just like it took me years for the shining ray to ping me in the noggin, I'm like, oh, that's what that meant. It can take practice and time to figure out the right way to make something readable. It takes a lot of practice in the use of our code language of choice to figure out the way to phrase something. Lean on the business domain, because it will provide you the phrases, the names, the verbs, the actions that you are trying to bring to value. It will help you to understand what it is you're doing, and where it does not have a provision for what it is you're doing because of how you chose to solve the problem. Rely on the ubiquitous language, or help make it become ubiquitous by leveraging the existing good patterns you know from our industry. And so with that, I'd like to take one more moment to bring to your attention that Improving will be hosting the Improving Edge Conference on the week of June the 7th. There will be 3 talks each day, each in a different track, all geared towards keeping you on the bleeding edge of technology in our industry and keeping you effective in leading in this time of change. So it is a completely virtual and a completely free conference. And I've gotten to look at the speaker list. there are several who I will personally recommend to your attention because they are phenomenal. So if you've got some time and are interested in more of this education, more of this learning, again, for free from Improving, please take a look at it. We'd love to have you.
Daniel, I had to say thank you for the haiku. That's the first I've experienced in the Virtual Lunch and Learn series we've done. We do this a couple of years, and it's I'm glad I got to be the guy that produced this one.
There you go. And if anyone wants it, just send me a message. I'm happy to send it out.
Thank you all for attending today's Virtual Lunch and Learn. And Daniel, thank you for sharing Code as Read. The recording of this session will be available the next business day. To view the recording, locate the session from Improving's virtual events page. As a reminder, all of our Virtual Lunch and Learns are recorded and shared for your convenience. As Daniel mentioned, Improving is hosting a free 100% virtual 5-day technology event called the Improving Edge Conference. We'll have 15 events covering a wide range of topics and invite you all to attend. You can register at theimprovingedge.com. Thank you all and have a wonderful weekend.